Continuing in this section, we're now going to look at a couple different trig identities, and we're going to use the ones involving tangent, secant, cotangent, and cosecant. So this is just these are formed by taking that sine squared plus cosine squared equals 1, and either dividing everything through by sine squared or by cosine squared. This is where these identities come from. And they can be used very similar to the first example I did from this section. So I'm going to start here, this one's very quick, with secant cubed x tangent x dx, and we want to integrate this. So I'm going to start by rewriting this as secant squared x times secant x tangent x dx. And if you remember, the derivative of secant x is secant x tangent x. So I can just go straight to a u substitution for this one. If I let u equal secant x, du is secant x tangent x dx. So lo and behold, I've got everything I need here. So I could rewrite this as u squared du. When I integrate, I get 1/3 u cubed plus my constant c. Since u is secant x, this just leaves me with 1/3 secant cubed x plus c. You could have worked this one slightly differently. Along with a lot of these other ones, this is what I found to be the quickest way to do it, and sometimes it's nice to find the quicker ways. But you can plug in, do it using different identities. The second one, this one's a little bit longer, and we're going to use, it's just the top of the screen here, we're going to use cotangent squared x equals cosecant squared x minus 1. So let me come down here. We're asked to integrate from pi over 4 to pi over 2 cosecant to the 4th power of theta d theta. I'm going to rewrite this one as cosecant squared theta times cosecant squared theta. And I'm going to take one of the cosecant squared thetas and I'm going to replace it with that trig identity. Cosecant squared theta is equal to cotangent squared theta plus 1. And then I'm going to distribute the cosecant squared theta here. So I have cotangent squared theta, cosecant squared theta, plus cosecant squared theta d theta. I can straight away integrate the cosecant squared theta. It just equals negative cotangent theta. For the first part here, though, I will need to do a u substitution. So if you want to, you can think of these as two separate integrals. And I might go ahead and do that because I'll change the upper and lower bounds when I do the u substitution. So for the first part, okay, I'm going to let u equal cotangent theta, then du is equal to negative cosecant squared theta d theta. So the only thing I'm missing is a negative. I can introduce that just by putting a negative in front. So I'm going to have negative, and then we're going to integrate u squared du. I do need to change my upper and lower bounds here. So if u is cotangent of theta, cotangent of pi over 4 is 1. Cotangent of pi over 2 is going to be 0. Then I'll write our second one here. We're looking from pi over 4 to pi over 2 cosecant squared theta d theta. So for our first one, when we integrate, we get negative 1/3 u cubed, and we're evaluating that one from 1 to 0. For the second one, we integrate cosecant squared, we get negative cotangent theta. And that one, we are integrating from pi over 4, to pi over 2. That is a pi over 4 down here. So what do we end up with? Well, we get negative 1/3 times 0 minus 1. Then over here, we've got negative, just like before, cotangent of pi over 2 is still 0. Cotangent of pi over 4 is still 1. So I've got negative 1/3 times negative 1, so that's a positive 1/3. Minus a negative 1, so that's a plus 1. So 1/3 plus 1 just leaves me with a 4/3.